Hey everybody, Mr. Bowman here. In this video, we're looking at 2.6 algebraic methods again, and our focus is on all the merit questions of the 2022 exam. If you're looking for more merit questions like these, check out the link in the description to this video. I've kind of put all of the merit questions in one place for your convenience. So let's get into question number 40. And this one here was a bit weird. I haven't seen one like this too many times in the exams before, but we've got this expression here. We've been asked to factorize it. And I can see a 3 needs to come out. I can see we've got some x's in common, and I can see we've got some y's in common. So I am going to be looking to take out something to do with the 3, some x's, and some y's. The trick here is the y's. So what I'm going to do is I'm just going to rewrite this in a way to see what can be taken out a bit easier. So we've got 6x squared. 6x cubed. That's the same. So y has a square root of y in it. So the square root of y times by the square root of y is equal to y. So we can actually see they've got a square root of y in common. So that was the trick to this question here. So we've got minus square root of y. Now that we've got that, we can take out all the bits we can. We know they've got a 3 in common, that we know they've got x squared in common, and we know they've got a square root of y in common. So the leftovers, so that's going to be 2x, because we've got an x left over, square root of y is left over, and we've got minus 5. Very early in the mornings, hence the math errors. There we go. And when you expand that out, you're actually going to get back to that. So hopefully you can see what I've done there. I've identified it's got a square root of y in common. I've split out my y into 2 of those, and then I've taken that y squared out with my basic factorizing in and around it. Now on to question number 41, and this here was a bit of a doozy. It took me a while initially to get my head around it, but I did in the end. So I guess the key thing to focus on is I won't read too much of the question, but basically they've got this area of a calendar for the whole year, any calendar, and basically what they're trying to say is if you do this number plus this number, that will always be the same as this number plus this number. And our job is we've been asked to show it algebraically. And down the bottom there, they've generalized for us, so they know our top left corner is always going to be A. So what I'm going to do is I'm going to start off by forming an expression. And my end goal here is I'm looking for an expression for the orange bits and an expression for the blue bits. And I'm hoping those expressions are equivalent. And that way I've shown it. So I guess the first thing to note, the expression for that, it's going to be A, which is going to be the first square, plus an expression for the next square. And the question is, how do you go from 18 to 42? That's 24 extra, isn't it? So that means this square here, if that's A, down the bottom there, this must be A plus 24. So I'm going to add that in there, A plus 24. And when I simplify that, I get 2A plus 24. So that's my expression for the orange one. I now need to repeat the same for blue, and blue is a bit more difficult. So I suppose to note is blue is here. So how do I go from A to blue? Well, that's going to be plus 3, isn't it? So my expression here is going to be, or you can't actually see that well over the blue, but that top corner there, that's going to be A plus 3. And then the next question is, well, what's an expression for this bottom corner down here? So the question is, how do I go from 21 to 39? Well, that's plus 18, isn't it? So it's going to be A plus 3 plus my extra 18. So that's going to be A plus 21. So I now need to add together these two here to form my expression for the blue squares. So that's going to be A plus 3 plus A plus 21. And I'm loving what I'm seeing here. I've got 2 A's, so 2A plus 24. And I can see an equivalent expression for both orange and blue. So I'm going to state that there. Therefore, orange is equal to blue. And now, because it's a wordy contextual question, I'm just going to explain my answer in context. So therefore, so it's going to be a bit annoying as I write this up. Therefore, the sum of orange corners will always be equal to, forgive my messy handwriting, to the sum of the orange corners. So the sum of the orange. Oh no, sum of the blue corners. I already said orange, haven't I? Sum of the blue corners. So we're now on to question 42. This one was a bit annoying. One of the achieved marks, which is that top part there, was actually intertwined with getting both of these right. So if you got both of them right, you ended up getting merit. So it ended up being stuck in the merit stuff. So basically the quick question is, what's the discriminant of that there? So let's do I. So for that question, we've got 2x squared, or minus 12x. So minus 12x plus 7 equals to 0. So reminder, your discriminant is when b squared minus 4ac. So whatever that comes to. So from my quadratic equation, I know that a was equal to 2, b was equal to negative 12, and c was equal to 7. So I'm going to substitute in my a, b, c. I'm going to mathematically calculate the number that represents the discriminant for this one here. So doing that, so b squared is going to be negative 12 squared, right? So negative 12 squared, and I'm putting it in brackets because I'm subbing in a negative number. And then I need to do minus 4 times a, which is 2, times c, which is 7. Getting all that, so negative 12 squared, that's 144. Don't write negative 144 there. A lot of math errors happened, I imagine. And then we've got 4ac, so that's going to become 14. 14 times 7. Nope, sorry, 8 times 7 is 56, isn't it? So we're going to go minus 56. And when I do that simple math, which it should have been, my discriminant is 88. So obviously in the exam, make sure you're doing this in the calculator. Don't make any silly math errors. You'll lose easy marks. So we're now on to II. And this part of the question is, so we've got a slightly different expression. They've taken away the 7. They put in k, which is a constant. And they've asked, when will this have exactly one solution? So this expression here, or this equation here, so y is equal to 2x squared minus 12x plus k. This here will have one solution when your discriminant is exactly equal to 0. So let's pull out my ABC. So a is equal to 2, b is equal to negative 12. That's the same as the previous question, but c is equal to k. So I'm now going to come up with my discriminant equation. So let's set up an equation. For this context, one solution, I know b squared minus 4ac must be equal to 0. I'm going to substitute everything in. So b squared, I know that's going to be 144 from the previous question, minus 4 times a times c. So that's going to be equal to 0. So that there just becomes 8k, doesn't it? So we're going to have 144, minus 8k must be equal to 0. Moving the 8k to the other side becomes positive. So we've got 144 equals to 8k, which means k is equal to 144 divided by 8. And plug that into your calculator, and you got 18. So that tells us if k is equal to 18, that's going to have one solution, which basically means it's a parabola kind of sitting exactly on the x-axis, so only one answer. Okay, so we're now on to question number 43, and I feel like this exam, these merit questions were actually a lot easier than the previous video I made, which was the 2021. So hopefully you get nice ones like these in your exams. So I've got an equation, basically I've just been asked to solve it, and straight away I know, because it's a square root, remember it could be plus or minus, so there's going to be two answers, which probably means we're looking to make a quadratic out of this. So I always look for hints as to my approach prior to starting the question. So I guess the first thing we can do is to move the square root to the other side, we've got a square. So if we square this side, that will cancel out the square root, and that means we've got to square this side. So that means 2x plus 3, remember the square root and the square have cancelled, will be equal to 9x squared. And a really common math error here is I imagine a lot of people wrote 3x squared at this stage. It's really common for people just to put the square on the x and forget about the 3, but don't be that person. We're then going to look to simplify this, so it's a quadratic. So 0 is equal to, I'm going to move these over to the other side. They both become negative, so that means 0 will be equal to 9x squared minus 2x minus 3. And I've got a quadratic equation, just like I've told us, already equal to 0. I can look and see if it's factorizable if you want, but again, I wouldn't stress about that. I would plug it straight into my graphics calculator. So to do that, I need to know that A is equal to 9, or I've written C, but B is equal to negative 2, and C is equal to negative 3. And when I did that into my graphics calculator, I got two answers. The answers were messy, so I needed to round to 4dp, but I got 0.6991, and the next two, negative 0.4786. And then I'm just going to state my rounding next step. Both of those had a 4dp rounding. So that question was real cruisy, a lovely merit question. Hopefully one like that comes up for you. So we're now on to question number 44. This video has flown by, a nice short one as well, which is good for the merit stuff. Basically, we've got a log expression. We've been asked to simplify it as a log expression. So I guess the key thing to note is when you're adding logs, so you've got log plus another log, don't forget about your log rules. And that's probably the Achilles heel of most students, to be honest. So log A plus log B, remember that becomes log A times B. So we can put them together. If it was subtraction, that would be it would be A divided by B, wouldn't it? So let's write down my expression. So I've got log 3A. So log 3A plus 2 log, and then that's going to be A over 6. I guess the first thing to note is this rule only works when there's no coefficient. So there's no coefficient of both of those. So what I need to do is I need to move the 2 back inside as a power. So that's my first step. So all of that's going to be equal to, so log 3A is unchanged at this stage. And I'm going to add on log A over 6, and that's going to be squared. Now that it's squared, I can actually simplify the fraction here. I can hit the square, so it'll be A squared and 6 squared. I can kind of almost expand that bracket over there. So I've got log 3A plus log, and that's going to become, as I said, A squared over 6 squared, which is 36. So now that I've got that, I've done most of them are here. I now need to times together my thing. So I need to times together 3A, and I need to times together A squared over 36. And I can put that as a single log when I do that. So that's going to become log, and that's going to be 3A times by A squared over 36. And just need to simplify the expression in the middle here. So that's going to be equal to, so log will be equal to 3A times A squared. That's going to be A cubed, right? So it'll be 3A squared over 36. And I can actually cancel out the 3's there, right? And that there will become a 12 on the bottom. So my final answer there would be log A cubed over 12. So that wraps up all of the merit questions in the 2022 exam. As I said throughout the video, I thought these merit questions are really cruisy. They're really, really nice ones. I think the 2020 video I just made before this, the questions were quite hard. So hopefully you get ones looking like these in your exams, but I would expect them to be harder in your exam. So prepare to a higher standard than these ones.